So for the rest of this unit, we are basically going to talk about how gases in containers behave under different environmental conditions. Each of the environmental conditions that we tinker with usually has its own type of formula to figure out what is happening to the gas. And usually each of these formulas has its own name associated with it. So the first formula that we're going to talk about is called Boyle's Law. I'm going to try to explain what Boyle's Law is first without the equation by just sort of describing something that should hopefully make a little bit of intuitive sense. So imagine that I have a gas in a container, and for most of these types of questions or these rhetorical questions that I'm asking, it might help to think about a balloon, so gas inside of a balloon, an inflated balloon. So here's my gas in a container. It's a balloon that's filled with gas. It has a volume, so this gas inside the container has a certain amount of volume, and you could figure it out if you were resourceful enough. You could actually figure out what the volume was in liters or milliliters or some other volume unit. It also has a certain amount of pressure. There is air on the outside of this balloon that is pushing against the air on the inside of the balloon, and the air on the inside is pushing back. And the amount of pushing that's going on the outside to the inside and from the inside to the outside is basically the pressure of the gas in the balloon. So our balloon has a certain volume, which we can put a number on. It also has a certain pressure, which we can also put a number on. And don't worry so much about how we could actually get those numbers. Just assume that we can get those numbers. So what Boyle's law basically says is if I increase the pressure on the gas in the balloon, then the volume of my balloon will decrease. In other words, if the air on the outside of the balloon presses more against the air on the inside of the balloon is going to shrink. And so hopefully that makes a little bit of intuitive sense. What Boyle's law also says is if I decrease the pressure on the balloon, so if the pressure from the air outside of the balloon doesn't push so hard against the air on the inside of the balloon, then the volume of the balloon is going to increase. The balloon is actually going to expand. And so again, hopefully that makes intuitive sense. So Boyle's law is basically saying if you increase the pressure on the gas in your container, the volume shrinks. If you decrease the pressure on the gas in your container, the volume expands. And mathematically what you say is that volume is proportional to 1 over pressure, which also, again, you don't need to know this. For the math nerds out there, this another way of saying this is that volume is inversely proportional to the pressure. And all I'm really saying with this math here is that if the volume goes up, the pressure goes down. And if the pressure goes up, the volume goes down. So, and more specifically what Boyle's law says is that if I change the volume of the balloon, I can figure out what the new pressure is. And if I change the pressure in the balloon, I can figure out what the new volume of my balloon is. Now, how you do that specifically, I will show you on the next slide. I'm going to describe Boyle's law by using a balloon as an example again. So here's our balloon. Imagine that the balloon has a certain amount of pressure on the gas on the inside of the balloon. And that's shown by these arrows. The arrows are showing the pressure from the air on the outside of the balloon pushing against the air on the inside of the balloon. And there's a certain amount of pressure, and I'm going to describe that pressure using the capital letter P and a subscript of 1. What that means is the 1 means what is the pressure on the balloon at the beginning of our experiment. That's what the 1 means. You can also see that this balloon has a certain amount of volume, and we're going to call that V1. So this balloon has an initial or a beginning pressure at the beginning of our experiment. This balloon also has an initial or beginning volume at the beginning of our experiment. And then we're going to change something. We're going to change some condition about this balloon and leave everything else the same. What we're going to do in this case is we're going to change the pressure on the balloon. So now we've increased the pressure from the outside air against the air inside of the balloon, and that's shown by the thicker arrows here. The pressure increases, and the way I'm going to describe that is I'm going to use a larger letter P, and I'm going to call this P2 because this is the new pressure compared to P1 over here. So our balloon, the air in our balloon has a new pressure pushing against it, and because of that, the volume actually decreases, and I'm going to represent that with a much smaller letter V, and I'm going to call it V2 because this is the ending or the second volume of our balloon when we change the conditions. So basically what Boyle's law is saying is that if you increase the pressure on the gas in your container, the volume goes down. So this letter got bigger, it went from P1 to a much bigger P2, and the V1 went to a much smaller V2. Now, again, this might seem like a long-winded way of explaining something that kind of makes sense already, but Boyle's law says something a little bit more mathematical. What Boyle's law actually says is that if you have an initial pressure and you double it, then the volume also goes down by double. If you triple your initial pressure, if you start out with a pressure of 1 and you end up with a pressure of 3, the volume goes down by triple. And the other way works as well. If you cut the pressure in half, the volume will go up by double. So these numbers, the P1 and V1, will always balance out for one particular gas in a particular container. And this sort of relationship that when you triple this, the volume goes down by triple, etc., can be written mathematically in the following way. It can be written like this. P1 times V1. What this means is the initial pressure times the initial volume of whatever gas you have in your container will equal P2 times V2. It'll equal the new pressure times the new volume in your container, assuming that you don't change anything else, assuming that you don't change the amount of gas in the container or the temperature of the gas in the container. So this formula basically is saying that if you don't change anything except pressure and volume, then you can figure out the new pressure and volume in a balloon if you know some of the other pieces of information. If you know P1 and V1 and P2, you can figure out V2. If you know P1 and V1 and V2, you can figure out P2 because P1 times V1 will equal P2 times V2. And I'm just showing it to you in a slightly more cleaned up form. This is usually the way that you'll see Boyle's law written. The initial pressure times the initial volume is equal to the new pressure times the new volume. And I will show you an example, a word problem relating to Boyle's law in a minute. The first thing that I want to show you, however, is a video sort of showing Boyle's law in action in real life. What they're going to show you, what you're going to see in the next video is going to be actually a couple of marshmallows being placed in a container where you can alter the amount of pressure. Initially, they're going to put the marshmallows in and they're going to decrease the amount of pressure on the marshmallows, and the volume of the marshmallows is going to go up. And then later, they increase the amount of pressure on the marshmallows and the volume of the marshmallows goes down. Now, you might say, well, marshmallows aren't gas. However, they do have a lot of gas, a lot of air trapped inside of them. And so Boyle's law more or less works for marshmallows as well. So you can watch the video on the next slide. Here is a word problem related to Boyle's Law. This is probably taken from your book. You have a balloon with a volume of 3 liters. So that's the initial volume of the balloon. The balloon also has a pressure of 1 atmosphere. And then basically the problem says you change the pressure on the balloon to 4 atmospheres. So basically you made the pressure 4 times larger. You started at 1 atmosphere, you increased it to 4 atmospheres. What's the new volume of the balloon? Now, intuitively, what I said is that if you make the pressure 4 times bigger, then you should make the volume 4 times smaller. And that is going to turn out to be true. You can try to work out the problem yourself. You can pause here, and I will show you how to do it in a moment. So here's the formula for Boyle's Law. P1 times V1, the initial pressure times the initial volume, is equal to the new pressure times the new volume. And basically all we do for these types of problems is we find the relevant information in the word problem and plug it in at the appropriate spot. So what's the initial pressure? It's 1 atmosphere. So 1 atmosphere is going to go here. What's the initial volume? It's 3 liters, so 3 liters are going to go here. What's the new pressure? 4 atmospheres, so 4 atmospheres will go here. And this last V, V2, is what we are trying to figure out. So we can substitute in all of those numbers like this. 1 atmosphere times 3 liters, those are just representations of P1 times V1 on the left here, is equal to 4 atmospheres, which is P2, times X liters. And we need to get X all by itself. So the way to get X all by itself is to divide both sides by 4 atmospheres. If we divide both sides by 4 atmospheres, X liters is going to equal 1 atmosphere times 3 liters divided by 4 atmospheres. You can see that the atmospheres in the numerator and in the denominator cancel each other out. The only unit we're left with is liters, which is what we're looking for. So X liters is equal to 1 times 3 divided by 4. 1 times 3 is 3. 3 divided by 4 is 0.75 liters. So if we increase the pressure from 1 atmosphere to 4 atmospheres, our balloon is going to go from being 3 liters in volume to 0.75 liters in volume. And so this is the more mathematical way of figuring out the new volume. But as I mentioned, you could have done this sort of in your head a little bit. We quadrupled the pressure on the balloon, so the volume of the balloon should go down 4 times. And so 3 divided by 4 is 0.75. So that's it for Boyle's Law. Basically, just to summarize, Boyle's Law is essentially trying to tell you what happens to the volume of a gas in a container if you change the pressure and don't change anything else, or what happens to the pressure of a gas in a container if you change the volume and don't change anything else. So that's Boyle's Law. The next section is going to deal with a different law called Charles's Law.